Okay, we're going to solve a moles to moles problem now. So there's a couple of points that I want you to keep in mind as we solve one of these problems. First, recognize that you must have a balanced chemical equation. Now, if you're in regular level chemistry, they're probably going to give you the equation balanced already, so you don't have to do anything. But if you're in honors or AP level chemistry, then you have to double check and make sure that the equation that was given was actually balanced. All right, now once you can confirm that that's true, then you can go on to the next step. Now the next step just involves looking at the coefficients of the substances that are involved. Don't worry if there are more than two substances in the problem. There probably will be, okay, but you really only need to focus on the two that the problem calls for. Those coefficients are the molar ratios, and those are very important because the molar ratios tell you how the proportions work. Kind of like when you're making a cake and you need to know how many cups of flour to how many cups of sugar. That kind of proportion is what I'm talking about. Those are the molar ratios. Now, when you know the molar ratios, you can create a conversion factor, and that conversion factor is built from the molar ratios of the substances in the problem. And you're going to use that to figure out how to convert from moles of A to moles of B. All right, here's the video, and I'll see you afterwards. Okay, here's a problem we're going to solve with moles to moles. Okay, so let's take a look at the equation here. We've got 2 carbon monoxides plus oxygen yields 2 carbon dioxides. Okay, so this is a chemical equation, and the way that I've set it up is I've given it to you balanced. Remember that if you're in regular or general level chemistry, they're most likely going to give you the equation balanced. You probably don't have to do anything. But if you're in an honors or AP level class, make sure that you check it out beforehand. Okay, so the question reads, what is the minimum number of moles of oxygen required to produce 1 mole of CO2? All right, so some important facts that you should highlight in this. First is they want to know the number of moles of oxygen, okay? And they want to produce 1 mole. Remember that there's the number 1 in there, 1 mole of CO2. All right, so in order to solve this problem, what you're going to need to do is you're going to need to start with the given information. In this case, the only part of this question that actually has a number is this one, where it says 1 mole of CO2. So you're going to write 1 mole of CO2. All right, that's your given information. That's what you start with. Okay, now, in order to go from carbon dioxide to oxygen, you're going to need to inspect the balanced chemical equation, because what you need is something called a molar ratio or a mole ratio. So let's check that out. So here is oxygen, and here is carbon dioxide. Now, there's no number in front of the oxygen, okay? So when this happens, you can safely assume there's at least 1 of that substance present. Over here it says that there are 2 carbon dioxides. So this could represent either 2 moles of carbon dioxide, or it can represent 2 molecules, but we're obviously doing a mole calculation here. So now that we know the molar ratios, we have to make sure we put the correct thing in the top and the correct value in the bottom. All right, so I'm going to make sure that we put our 1 mole of oxygen in the top, and we're going to put 2 moles of CO2 in the bottom. Now the whole reason for doing this is we want to make sure that the moles of carbon dioxide cancel. Okay, what's over here is going to cancel with what's down here. And that's going to be true of every problem that we solve with dimensional analysis. Now you don't cancel the numbers, you're just canceling the units. And make sure you write this down, because if you get lost, this will kind of help you figure out what happened. All right, now we're going to actually solve the problem. 1 times 1 divided by 2. All right, last time I checked, 1 times 1 is just 1. And then, of course, a half written as a decimal is 0.5. So our final answer is 0.5 moles of O2. And that's our final answer. Now, it's possible that on a test, you may see the answer written as a half a mole, It depends on your teacher. I would say that more than likely, most teachers are going to leave their answer as this. Okay, they're usually going to use decimal numbers for the answer. So don't be surprised if you see this. Okay, well, that's all we have to solve a moles to moles problem. Just to recap, you start with the given information, which came from the problem. You need some kind of conversion factor that comes from the balanced chemical equation. And remember, you only need to focus on those things that are involved in the problem. You don't have to worry about this guy at all. All right, forget about it. Just focus on the oxygen and the carbon dioxide, and you're all set. Okay, you just got done watching the moles to moles video. So let's recap the most important points. First, you must start with a balanced chemical equation. Can't get around that. If you're in regular level chemistry, they're probably going to give it to you, but if you're in honors or AP, watch out, okay, because they do like to trick you with that stuff. Second is once you have the balanced equation, you look at the coefficients. The coefficients give you the molar ratios between the different substances. And then from that, you're going to create a conversion factor. I recommend that you take the time to download the worksheet and solve this problem on your own and follow all the steps. Even if you know how the problem is supposed to be solved, just the act of taking the steps and following the steps and practicing the steps is really what is going to train your brain for following the correct procedure in these kinds of problems. All right, that's all I have. Watch another video, and I'll see you next time.